Alright, welcome. In this video, we are going to take a look at an extra piece of functionality you might be thinking about adding to your game, and that is gamepad controls. This can be a good idea for a game because it might make it easier for the user to control your game, as opposed to having traditional keyboard controls. First, let's start off by saying that there are no gamepad listeners, so we will have to use the Gamepad API. On this slide, you have a link to some resources that I found useful when implementing the gamepad functionality in Mario, and that is the MDN docs and an extra useful article that outlines several buttons that you might be interested in using. Moving on to the basics, your operating system will automatically detect up to 4 controllers that are connected to your computer. They can be either wired or wireless. Navigator.getGamepads will return up to 4 gamepad objects. You can access the one you want by specifying an index from 0 to 3. In my case, I did let gamepad1 equals navigator.getGamepads of 0, since for Mario we are only going to be using one gamepad. However, if you have a game where you want to use up to 4 controllers, maybe support a 4-player functionality, you are going to have to take each of those into consideration. For simplicity's sake, we will use gamepad1 instead of navigator.getGamepads of 0 in the next examples. Some important concepts. For a web-based game, we need to update the controller with every tick. That is why we reassign gamepad1 in the game engine update. To get info about how the user interacts with the gamepad, we are interested in buttons indices 0 up to 16 and axis 0 up to 3. Moving on to the buttons, those are very important. You can check if a button is pressed by checking the boolean value gamepad.buttons indices from 0 up to 16 pressed, and you can see this table is from that other website I linked. It covers all of the buttons that you are interested in, either on an Xbox or a normal PlayStation controller. You can see you have all of the buttons that you might need for your game. Lastly, we have the stick axis, and gamepad1.axis of 0 up to 3 is the number between -1 and 1. -1 represents left on the x-axis or up on the y-axis. 1 represents right on the x-axis or down on the y-axis. Also, axis of 0 is the x-axis of the left stick, axis of 1 is the y-axis of the left stick, axis of 2 is the x-axis of the right stick, axis of 3 is the y-axis of the right stick. As you can see, they are paired up, so it should not be hard to think which one you should use. Alright, now let's take a look at some of this functionality and how it is built up into Mario. Here on the right, you can see my controller. I'm putting that up only for visualization, so it's easier for you to notice what I'm doing with my controller. So as you can see, I can go through the menu options using either the stick or the D-pad. Also, with that button I can toggle debug on and off, or with this one I can toggle the mute on and off. Also, with the right stick on the x-axis I can change the volume. Now let's take a look at some of the changes that have been made in Game Engine to support the gamepad functionality. First, as you can see, we are interested in using those properties also for the controller. We don't want to add a lot of properties. So going down, this is the function that we are interested in. It's gamepad update, and we call it in the Game Engine's update. First, we retrieve the gamepad using navigator.getGamepads of 0. We assign that to this.gamepad, and then we perform the various operations on each button, we are going to evaluate whether any of them are pressed or not at that time. However, you can see that we only go in this block if the gamepad is not null and the keyboard is not active. What that property means, as you can see up here in the key down event listener, keyboard active will be set to true on the key down when we enter the function, and also it's going to be set to false on the key up event also when we enter the function. That is important to keep track of, because let's say you would want to be able to easily switch between gamepad and a keyboard control while playing the game. And so if we would not have this keyboard active check right here, the controls would overlap with each other. Let's move to Scene Manager and take a look at some of the changes that are there. The two critical changes are the menu button timer and the menu button cooldown. That allows you to go up and down in the menu and also press buttons, various controls, as you see, the volume. And that is important because we don't want to be able to press a button, because that's going to activate it a lot of times with every tick. So it's going to flicker. That's not what we want. We want a seamless transition. So I kept track of those, this timer and cooldown. Let's take a look at the update function in Scene Manager. As we start off, we see that we increment the button timer by the game's clock tick, and in the main menu or the credits screens, a command like pressing up or down on the keyboard or the controller, it's only going to go through if the button timer is greater than the cooldown. And after setting after going through with each of those commands, we want to reset the timer back to 0. Same is said for the credit scroll feature, because we don't want to be able to scroll that credits so many times within the small ticks that the game has. We want to keep that cooldown as an ability to control how that animation will look. And one last detail is that we also keep track of the timer and the cooldown for the debug, mute, and the volume slider functions. That's it for this video. Hope you found it helpful and you'll be able to implement those features in your own game as well.